Welcome back, you guys, to October's AMA session. We're so excited to have all of you guys back here tuning in from all over the world. It's going to be an amazing presentation, a great morning or evening for you because we do have people from all different time zones. Ruben's going to give us a little bit of an idea of what the itinerary is going to look like, and then we're going to dive right into it.
That's right, Misha. Has been so much fun. A little bit over 2 years since the helicopter was publicly launched in August 2020. What a journey. We have had probably, 20 of these Ask Me Anything sessions, and it's going to be, as usual, Jason's going to present the latest and the update of the helicopter, what has happened in the last month, and actually since our last event, a global meetup and discovery event in August, beginning of August. So Jason's going to present for about 40 minutes. And as usual, after that, we call it the Ask Me Anything. So it means that you can ask anything you want. We're going to have the chat available on the right side of your screen. You can put there your questions, and we're going to be then taking turns, Misha and I, at the end to have Jason answer those. So without any further delay, I want to welcome again Dr. Jason Hill, the founder and CEO of Hill Helicopters. It has been a journey for him a little bit longer than us. Has been now 12 years since the start of the making of the helicopter, which is now getting very close to that finish line. So Jason, welcome. It's your stage to update us all.
Thank you, Ruben. Thank you, Misha, and welcome everybody back to DC1 here at Rugeley. So this evening, I'm going to give you a presentation in a familiar format. I'm going to give you a little bit of an update from across all aspects of the company, and then we're going to dive in and talk specifically about the stuff you all want to hear about, how the airframe's coming along, how the drivetrain's coming along, and how the digital cockpit is coming along as well. So let's make a start with the sort of outlook. Essentially, Hill Helicopters is a company that's taking the helicopter industry back to basics. Our business model is really very simple. Build an aircraft that people actually want, deliver it at a price point that they can afford through our vertical integration strategy, and then provide the levels of end-to-end support that customers buying premium products from around the world really expect. It's that simple. And of course, when you do that, what you find is the market responds. And as of today, we've sold 540 HX50s, 116 HC50s, and quite honestly, there has never been a better time to be able to join our movement and purchase your own HX50. We've got vast pent-up demand in our sales pipeline. I think we're up to nearly 4,000 people now that are just waiting for us to hit a specific gate in the development program then they're in. Couple that with the fact that the pound is at a 40-year historic low against the dollar. Now really could be the time for you to come and join us. And what I'll do tonight is give you a good reason to come and join us by showing you how we're developing across the program. So those of you that are in the UK will be aware that our global headquarters, our 335,000 square foot production facility, is currently going through the UK planning process. Our first planning application that deals with an existing application for an industrial building on the site is in the system. All the comments and response phase of that program is now complete, and that's waiting for the second of our applications, which deals with the flying aspect of the heliport that we're building to be submitted. That is being submitted over the next couple of days. They're just dealing with a couple of last issues, and then that will go through, and we expect to have some feedback from the planners early next year on that. To put those in the UK and those in the area's mind at rest, the building really takes every opportunity that modern technology affords to be able to minimize the impact that our operations have on the local environment. So a lot of the operations that traditionally would have been potentially noisy will be done within the building or within acoustic chambers within the building. So we really are going to be the friendliest neighbors that is at all possible. We've had great support from the local government, and we're very much looking forward to getting started on building this impressive modern manufacturing facility. To support all of that, it's one thing having planning permission for what amounts to a big box, but also there's a huge amount of stuff that has to be done to develop a state-of-the-art helicopter production facility. And we've recently taken on a new lead engineer to support us in developing the production, the sort of development of the assembly process, the development of how we organize and manage ourselves throughout production, the logistics that support all of that, and all of those activities. And that work is now underway, which of course supports the detailed design of the factory building itself and the support services that go into that. The event that we've just completed was very much a watershed moment for the company. When a development program is in its early phases, the business needs to be an extremely agile and flexible and relatively unconstrained operation to sort of nurture and support widespread innovation in all the areas that you need to create something like HX50. And our organization and the way we operated really reflected that. Upon getting to the recent event, we've now reached a turning point in the way that the business needs to operate, because the design and the systems and the manufacturing processes are sufficiently mature now that we really have to change gears and work in a different way that's much more disciplined, much more controlled, and will really support faster and more efficient progress as we focus on showing compliance with all of the necessary regulations and things that we have to show, that we have to evidence that we meet for this thing to be allowed to fly. So off the back of the event, we've essentially completely reorganized ourselves and upgraded the way that we operate as a business into a much more focused and compliance-orientated organization. Sounds very boring, but it's actually really important for what comes next, which is taking those designs and systematically going through them, testing them, proving each part, each subsystem, each assembly, and then the aircraft at large is fit for purpose and robustly meets the very latest airworthiness standards. So there's been an awful lot of work going into that over the course of the last couple of weeks. In addition to that, as you know, we are simultaneously developing both the product, the processes that make the product, and also the business, all in parallel to give us the most expeditious route to market. There's a number of things that have been going on in DC1, 2 and 3 over the course of the last month to enable us to do these things. One of the things that you might notice when you look around the facility here is that we've put temperature controls and air conditioning in throughout the precision engineering facility. You will have been following over recent months that we've been doing a lot of work on developing high quality aerospace grade gears, bearings and other precision components. And when you're working to the tolerances that we need to deliver premium quality, reliable components, then you really do have to control everything. So we've put temperature controls in here so that all of the materials are long soaked at the right temperature. They're all stored at a controlled temperature. The machines themselves over a period of weeks have stabilized to a controlled temperature. Even the coolant, the cutting tools and everything that touches the part is stabilized at a controlled temperature. Because when you're chasing single figure microns to make these components, nothing can be left uncontrolled. Otherwise you simply won't be able to do it. So all of that work has been completed here at DC1, and we're now in a position where we've got the level of control that we need over all of these things to be able to repeatably produce these sorts of precision components. We showed you probably 2 or 3 months ago now that the first of our CMM measurement equipment was delivered. That was really a machine to get us started and handles the bigger, less sophisticated, less tightly toleranced components. While most of the attention now is being focused on producing gears and bearings and super high tolerance parts, we need another level of measurement capability beyond that. So we'll soon be receiving a hexagon CMM machine, which is actually capable of measuring down to 0.1 of a micron. So that's 0.1 of a thousandth of a millimeter is the accuracy that that machine can work to. And we're also shortly going to be taking delivery of some very, very specialized bearing measurement equipment, so that not only while we're developing the products, but also when we're in production, we can measure production items really, really quickly so that nothing slips through the net from a quality perspective. We've also invested in part marking systems. We're obviously producing a large number of parts now, and it's important that we can part number them, serialize them, and track all of the parts as they start to progress through the production process. So part marking and the laser engraving that we've got is one side to it, but you also need to introduce the manufacturing system control systems as well, and all of that work has been going on in the background. We're taking a very light touch to that at the moment before we step up to production grade systems, again just to keep it simple, agile and responsive as we go through this phase of development. And then the other big news in terms of infrastructure development over the course of the last month is our beloved 5-axis gantry mill machine that was responsible for the production of all of the patterns that built the first set of molds for HX50 is having a brief break, and we're giving it a well-deserved upgrade. So we're reconditioning the spindle, reconditioning the ball screws and bearings, and getting that machine set up for a long slog in production over the coming years. So over the course of the next 3 to 4 weeks, we should be restoring that machine to as good as new condition, ready to make the production patterns and the production foams, the production trim tools, and all of that great stuff, as well as doing the trimming on the first carbon fiber HX50 fuselage. So really pleased to see all of that coming together for us. Let's now dive into the airframe, and I'll give you an update on how the team's been developing the HX50 monolage and all of the technologies that go into producing cost-effective, high-performance composites. You will have watched over the event that we held recently that we've essentially pulled a range of processes from a number of different industries to fuse industrial levels of cost effectiveness with aerospace grade performance and quality. And our process is really largely borrowed from the boat building industry, where we take low cost materials to make the patterns, we apply a series of surface treatments, so a fiberglass layer, a tooling paste layer, have a secondary machining operation, and then that is the pattern from which we can take our tools to then make the fuselage. One of the challenge with an infusion-based composites process is the fact that you absolutely have to generate vacuum integrity. If you fail to be able to hold a robust vacuum, then you simply cannot infuse. And so one of the things that we've been going through and doing very systematically and very methodically is the development of the exact recipe that we're going to use for the test fuselages and the production patterns that will go on and make all of your aircraft. And so the recipe that we've used is essentially being illustrated on the slide that you can see in the background, where we've had to take great care to make sure that at every stage of the process we're able to create essentially an envelope bag environment around the envelope that draws the vacuum down on the fiberglass. And what you can see just over here, if we just move over to this stand over here, what we've got here is a small demonstration of the recipe. It doesn't look very sophisticated, but there's a lot of technology goes into this. So Milan, if you just jump up here a little bit, you can see we've got the conventional polystyrene base, which means we can make vast tools inexpensively. We then have a fiberglass layer on the top. That gives the backing material the strength it needs to be robust in operation. And then on top of that, we then need to apply a sealant layer. And this is the layer that creates the bottom half of the envelope through which we bag the carbon fiber or glass fiber, depending on what kind of tools we're making. And then what you can see in here is that you can apply tooling paste to that top layer, making sure to leave some sealant out to the outside, or we can go directly onto this as we have here. And this is a glass fiber mat that we've got in there, which is representative of some prototype development tooling we're making at the moment. And this vacuum bag has actually held a vacuum now for 2 solid weeks without being connected to a vacuum pump. So really, really pleased with how this has come together. And what this now means is those vast patterns that you saw us make on the run-up to the event can now be sealed, and we can produce high-quality, production-grade tools from those relatively inexpensively. So great progress on that front. The very next stage of this is to develop the infusion process. So one of the key elements of HX50's fuselage and composites is the use of the infusion process, which allows us to come out of the autoclave. It allows us to use inexpensive forms of composite materials and still allows us to produce high quality, high integrity mechanical parts. But infusion's pretty tough. It's a more complicated process than using traditional prepregs, and it just needs that care and effort to be paid when you're developing it. So over the course of the last month or so, the composites team have been systematically working through the different process parameters that are required, not only to produce the very thin laminates that go into forming the monolage and the tail boom itself, but also the thick laminates that are required to produce the tooling and the seal channels that are necessary to bring those big elements of tooling together. And I'm happy to report today, and if we just pop back over there for a second, Milan, that through the careful selection of the correct fabrics, the correct stack up of the infusion media that we use, the correct infusion strategies, we're now able to produce high quality thick laminates in both carbon, so this is what the production tools will be made out of, and also in low cost glass fiber, which is what some of our development tools are made out of. You can also see that we're now able to make high quality, high integrity seal grooves within these parts that allow us to get a robust seal between the individual molds that make up the outer shape of the HX50 fuselage. So all of those key nuanced elements that are required to make high quality composite parts have now been nailed down into formal processes that we can now apply with great confidence as we build these parts for the aircraft. So one of the other checks that we've had to do with the patterns and the molds that we've been producing is to ensure, like all the other components that we make, that they conform to drawing. It's vital when you're manufacturing parts that you manufacture what you think you've manufactured. The thing is the right size and shape so that all the bits and pieces fit together and work properly. So in order to assess the quality of our in-house CNC machining, our in-house pattern making and assembly techniques, and then all of the surface coatings and all of the treatments that we have to provide to these patterns and molds after we've machined them, we've been and carried out a laser scanning investigation into the A surfaces of all of the patterns that we've produced. So what you can see in the video behind me is a simple laser scanning process that then gives us point cloud data that allows us to see where the bits that we've made lie in space relative to what the drawings and the CAD models said they should be. And what we found is, even with working through all of these things as absolute prototypes, the very first ones we made, we're robustly holding between 0.5 millimeter in most areas of most of the molds, and in the worst case up to about 1.5 millimeters. And for parts of this size with these sorts of processes, that's more than good enough for what we need. And I think with a little bit of care and attention and refinement, we should be robustly able to hold around the 0.5 millimeter mark in the production tool. So really, really pleased with how that's coming together. Delighted now, and we can get those things now straight into production and move forwards and start making this first fuselage. Now, to support all of that, there's a bunch of other stuff that you have to do. We have to get the vacuum bagging techniques right. We have to get all of the kitting techniques so that we can cut all of the individual pieces of carbon fiber, and in some cases glass fiber, put them all together into the stacks we need and load them efficiently into the tool, getting them to conform to those shapes in the tool. And all of those processes have been refined somewhat over the course of the last month as well. So these aren't quite yet at what I would call production ready. They're not fully automated. It's still very laborious, but we've got those down to an area where we're really satisfied with how the whole thing's coming together. And so essentially, as of about 3 hours ago, we've taken the first new mold of the belly of the HX50 fuselage using the latest pattern formulation, the latest laminate formulation, and the latest infusion techniques. And that infused beautifully over the course of about 2 hours. And again, I should remind you, that's a really thick laminate that we're doing there, so very challenging for infusion. So that all seems to have gone really well. So over the course of the remainder of this week and next, we'll be infusing the remaining patterns that are ready to go. And the very next step is that we go and start doing the process development to be able to infuse that first full-scale fuselage. So in order to do that, what the guys have been doing over the course of this week is getting all of the foam cores that we've had machined that essentially provide the guides so that we can lay the B-surface carbon down, and it creates the structural members within the monolage that we require. Getting all of that assembled, checking tolerances, checking the fit, checking, you can see it there sitting on one of the belly tools that we created previously. And then we've also got a range of metallic inserts here. So these are the inserts that actually get buried within the foam and the carbon fiber. And then these are the things that all of the mechanical components attach to. So this is one of the gearbox mounts that sits on the roof of the fuselage, and we've got similar mounts to mount the tail boom, the undercarriage, and all that other good stuff. So all of these have now been produced, and they're waiting to go into the foams and waiting for for us to be able to essentially produce that very, very first HX50 fuselage. So really pleased with how all of that's going. During the event, we showed you the very first HX50 crew seat. So this was essentially what we would call a technology demonstrator, a proof of concept prototype that shows that we can produce an infused carbon shell that carries all of the loads we require. Within that, we can nest the mechanical components that house the proven energy absorption devices that we've developed, and then we can machine, sculpt, and shape contoured seating foams, and then trim all of that to the level that you would expect in a £500,000 vehicle. And we demonstrated all of that, and that was all well and good. But now the real work starts, because now we've got to go and productionize and optimize all of those sorts of things. So what the guys have been doing over the course of the last month has been very much focused on the productionization of the composites. So if we just go over here, I'll show you what we've been doing on the crew seat development. So what you see here is the technology demonstrator seat that we featured within the event we did last month. So a beautifully trimmed, comfortable crew seat that basically meets all of the parameters that we need it to for the aircraft. Within this seat, we showcased the carbon fiber structural core that goes inside. This is what carries all of the structural loads, keeps you in your seat in the event of a crash and a rollover, and transmits all of that back to the airframe. All well and good, but what we've got to do with this original one was made with pre-preg to expedite the overall process. So since then, we've been focusing on producing infused parts that get the cost down to a level that's tolerable for a production aircraft. So we started by essentially just making the front skin of the seat core. And what you can see here, this is one of the early attempts. It's fantastically light, but this is one of the early attempts with just a couple of plies of carbon in there. And what you can see if you look very closely is at the top, we've got areas where it wasn't properly wetted out by the infusion process. So we've got carbon fiber there, but we've got no resin. So that fiber doesn't do anything for us structurally. So over the course of a week or so, we refined the process, we refined the infusion parameters, and then produced this second example over here, which you can see as fully infused. So there's no dry spots here. We've got total composite integrity on this part. And once we've got those parameters locked down, the very next thing that we did is to produce a full carbon fiber seat. So this also has the front skin, but if you have a look around the rear of it, you can see we've got the structural foams in there, and also the B surface on there that creates the big box sections that carry the bending loads that secure you in your seat in the event of a impact. So over the course of last month, we've taken the technology demonstrator and essentially proven that all of the production processes that we're going to come to rely on produce high quality composites, and also allow us to use the infusion process, which delivers the price point that's vital to us all. So really, really pleased with how that's come along. Let's go back and have a look at what we've been doing mechanically. So let's talk for a second about the drivetrain development and the GT50 engine. So our strategy has been very clear across the whole project. We do all the difficult things first. So in terms of producing a helicopter, helicopters, as we've said before, are very much machines rather than aircraft. And the things that we really have to be able to produce really well and really cost effectively are the mechanical drivetrain components and the gas turbine engine. If you can't do that, you can't hit the price point. So that's where a lot of our mechanical team have been focusing their efforts. On the run up to the show, we demonstrated that we could produce the entire main rotor transmission. We demonstrated that we could produce it here on our own equipment, we could hit the price point, and we could make these components sufficiently quickly that would scale up into production. All that stuff works great. What we've got to do now is to progress that towards a production-ready process. So the very first thing we had to do is essentially tear down the main rotor gearbox and go back and inspect all of the components. To hit the deadline for the show, we didn't have time to do all of the inspection that we would do as part of the prototyping process to validate the dimensional accuracy of these components. So we've taken the gearbox back to pieces again, and all of the gears and the critical components have gone off to one of our measurement partners while we wait for our new CMM to arrive to be produced. So the gearbox process has validated the assembly. It's validated we can produce the gearbox. We've still got the lubrication tests to do on it, which we'll do when we get the whole thing back together again. And what I'll show you now is that we've also now validated that we can produce these gearboxes to exactly the tolerances that we require. So gears are really complicated. When gears mesh together, we have to control the tolerances and the geometry of the teeth really carefully so that the load is shared between adjacent teeth uniformly to control the size of the contact patch. If you don't do that, you'll end up with all sorts of fatigue and wear problems that would be horrible. And so the level of precision and detail that goes into designing a helicopter transmission is extreme. So what you can see on the slide behind me is Mark has taken all of the gears that we've produced up to Dontine, our partners up in Newcastle, and they've been using their gear measuring equipment to go and profile the performance of profile the geometry of the gears and verify where we are in terms of the tolerance range that we've been able to achieve. And these are the reports that we've had back from Dontine, and I'm delighted to be able to report that we are currently making gears, even the prototype gears, with the exception of a couple of outliers. All of the gears are already hitting the tolerances that are conventional for US helicopter manufacturers. So on the equipment we've got here, based on the cost base that we've declared, we are able to make these gears and gearboxes, and we're able to do it right now. So, so that isn't the end of the process. There's a bunch more there's a bunch more process development to be done in terms of the hardening and various other things we need to do. What we've got to do now is go and optimize these processes and see how far we can back off these quality parameters to maximize the productivity of each of the machines. We've had a couple of calibration issues, which were fascinating. We were able to see an error in the machine's calibration in the reports on the gears. That's subsequently been fixed. And I should also say that these results that we've had here were all generated before the latest temperature controls and production controls were put in place here. So over the course of the next month now, we'll do the hardening on the gears, we'll do the hard machining, and we'll also just map out process capability so we know exactly where we can pitch these tolerances in production. So really, really pleased to report that we're on top of things with the drivetrain. As soon as the gearbox goes back together, we'll verify the lubrication system, and then we're on to bearings. So, in terms of bearings, bearings are one of the other areas where we've had to really take an unusual step for a small manufacturer and go and produce bearings ourselves. And this is very much based on controlling the costs so that they remain acceptable for the GA market. In the existing transmission that we've produced, we've used off-the-shelf industrial bearings just to demonstrate the function of the gearbox and everything else that goes into the gearbox. And what we're doing now is we're substituting those bought-in bearings with Hill manufactured bearings. So what's been going on over the course of the last 3 to 4 weeks is Mark and Paul have been really driving down the tolerances and the controls on the bearing races on the first in-house bearing that we're producing. And we're producing a bearing that will work in this form factor here. So what you can see here is we take raw material, as we do with the gears, and then using our CNC lathe, we're able to hard machine this specialist bearing steel down to around between 4 to 6 microns, and then we give it the finishing licks over there on our CNC internal external grinder. We've developed a range of temperature control processes, some very, very specialist work holding, so that we can actually support these components in the machine without having to clamp them in a 3-jaw chuck. If you look at the video, you can see the roughing is done while you still hold it in a 3-jaw chuck, but to get the finished profile into the bearing, it's vital that you don't put any radial distortion into it by clamping it inappropriately. So all of those processes have been developed, and we're currently producing the first of the in-house bearings. And again, true to form with all of this, we're going after the most difficult ones first. So the bearing that we're producing is actually the forward gas generator bearing. That's a bearing that lives in a hot, difficult environment and sits at 50,000 RPM for 5,000 hours. And so that's the one we're doing first, because if you can do that one, you can do any of them. And as they get bigger, of course, it gets easier to hit the tolerances. So lots of progress on the mechanical front, and all of the key mechanical jewelry that goes into this helicopter is maturing really nicely. Let's talk for a moment now about the engine. As I discussed at the last event, we've really seized the opportunity to take this sort of once-in-a-decade opportunity to make sure GT50 is the best that it can possibly be. The lightest, the simplest, the most reliable, the easiest to maintain, and the most cost-effectively both to manufacture, to own, and to operate. And to that end, we've been doing a lot of work in-house in developing and enhancing the engine team here at the company. We've appointed a new engine chief designer, we've appointed a new engine chief engineer, and those two guys are now increasing their headcount to make sure we've got all of the people and the skills we need to push through this final stage of development and optimization of the engine. Now, I've talked to you a little bit about the issues that we've been having in making sure the secondary air system is as optimal as it can possibly be. Let's go and have a look at the first gas generator that we've produced, and I'll explain to you what we've been doing and why on the actual hardware. So this is the very first GT50 gas generator rotor, and this is a design that's been stable for around 2 years now. So we've got single-stage centrifugal compressor of a very well-known and understood design. We've got a 2-stage compressor turbine, cooled first stage nozzle, uncooled second stage nozzle. Now, the most difficult part about designing one of these rotors is because they spin so fast, you can only accept a very, very small bearing to support the shaft. Because if the bearings get too big, then the centrifugal loads on the balls will become so high that they lift out of their lubrication film and skid rather than rolling, and that will rapidly destroy the bearing. So what we've been having to do, and the implication of that, of course, is that it means there's a limit to the axial loads that you can take on the rotor. So what we've been doing is optimizing the secondary air system so that we limit the load on the axial load on the bearing to just enough. It can't be too big, it can't be too small, it's got to be just enough so that those bearings operate in their sweet spot and work properly. Now, what we found is that although the 2-stage compressor turbine is a really sweet, efficient design. It does make the secondary air system more complicated, and it does lead you to a relatively small diameter turbine. And so what we've opted to do is to move to a single stage compressor turbine. So this is the updated general arrangement that you can see here. So we've still got the single stage turbine, but what you can see now is we've got a single stage compressor turbine to power that. This thing is slightly higher loaded, but with the improvements to efficiency that we get in the secondary air system overall, the overall benefit on the engine is a slight efficiency improvement, even with a slightly higher loaded turbine. So what that does is it shortens the length of the engine, it reduces the number of superalloy components that we've got to make, and it gives us a very small increase in performance while giving us a much more robust and reliable secondary air system. So that's the work that the guys have been focusing on. The secondary air system is now mature. The updated compressor turbine is currently being respun at the moment, and that will cause a slight growth in the annular combustor as well. All of those things are in hand, and that then should allow us to, subject to analysis, freeze the design of GT50 ready for the remaining components of this assembly to be produced so we can get the thing on test. So really pleased to see that coming together. Let's have a look now at some of the parallel development that we've been doing on the manufacturing processes that are required for the GT50 engine. So we've talked previously about the machine components. You've seen us make the compressor. We've got casting processes in development at the moment to make the superalloy blisks and nozzles. We're looking at 3D printing for some of the other bits and pieces. But one of the areas that we now need to focus on is the precision fabrication of superalloys. Okay, so sheet metal superalloys. And for that, there's a bunch of operations that we need across a number of the components in the engine. So we need to be able to roll and press and form and drill and join sheet metal components to make ultra lightweight precision metal component casings, exhausts, and also the combustor liner. We've been and done some exploratory work with a company in the UK to provide a 5-axis machine that can simultaneously weld the individual layers of the combustor together, as well as drilling the 2,000 plus precision holes that we need in the combustor liner to feed in the dilution air and also to feed the blanket of cooling air over the metalwork. We've managed to work with those guys. We've proven that that process can do what we want it to do, and we've shown that the economics of that work for us as well. So we're now in a position where we've identified everything that we need to be able to make the entire engine. There's a little bit of work left to do on castings, but beyond that, we're in a great place with the engine. So in addition to that, while we've been procuring the external third-party machines, we've also been building some of our own equipment. So if we just quickly go and have a look at this piece of equipment over here, this is called an expander. And the combustion liner that we need to make is actually formed from sheets of superalloy nickel, okay? And this starts as flat sheet, it's laser cut, and then it's rolled into a circle, welded, but of course that isn't a perfect circle. So what we need to do then is pop this thing on a machine, and then we've got some pie slice tools that go into this machine. This thing's pulled down by a hydraulic ram, and that then expands these things so it's perfectly round and perfectly to size. And then we can stack these rings together. They go onto a fir tree kind of jig and fixture, and that's when we can put them into the 5-axis laser and drill these cooling and dilution holes, and also weld these things together to form the annular combustor. So the combustor's well on its way at the moment. We're just waiting for the respun geometry for the new single-stage compressor turbine, and then that is the sheet metal work ready to go out for prototyping. So really pleased with how that's coming along as well. Okay. So let's talk about the digital cockpit for a while. During the event, we introduced and showcased a fresh new look for our iconic digital cockpit. So the DigiCockpit is a very simple idea. Just do what's necessary and nothing else. Manage the workload for the pilot and make VFR flying as simple and intuitive as it possibly could be. That's the idea, but behind all of that, there's a bunch of really technical stuff that you've got to get right. Fundamentally, certifying and approving software is a relatively big deal. It's complicated and it's long-winded. So it was important that we built the digital cockpit on a fundamentally certifiable platform. So a lot of the work that's been going on over the last few months has been about transitioning the concept of the DigiCockpit into an environment where we can eventually certify it in the short term, approve it for use on experimental aircraft. We're developing all of the software both for the DigiCockpit UI and UX and also the interface applications that communicate and control with all of the third-party peripheral systems like the radio, the transponder, the GPS, the AHRS, and all that sort of stuff, developing all of those in-house. And then, of course, we've developed a much more robust approach to the supportability of this thing in the future. It's no good having a quirky screen size that we can buy today, but might not be available in 10 or 15 years' time, leaving a simple fault causing a big problem for the aircraft. So we've dealt with all of those issues and are undertaking a very, very significant development at the moment on the UI, UX, and all of the underpinning hardware behind it. So for those of you that haven't seen it recently, the DigiCockpit has got this fresh new look. The same basic concept, but with much cleaner graphics. The key point that we're going to talk about today is how we've been developing a layered approach to the DigiCockpit. So what you can see in the blacked out areas is the radio bar, the control bar along the bottom, the fundamental gauges, and then behind that, what we're showing here is a fixed synthetic vision image that represents your artificial horizon. Now, that transparent layer can be populated by synthetic vision. It can be populated by a background 3D image, a computer-generated image, or it can be a feed from a camera. And so what we've been doing over the course of the last month or so is developing the technology that's required to bring all of that together in a way that will eventually be approvable and then certifiable for the HC model, because we want consistency between the two platforms. So the platforms and hardware that we're developing are inherently modular. All of the peripheral systems, the radios, the AHRS, the audio panel, all of those are interchangeable. So we can update the DigiCockpit with no impact on the user, swapping out those units as we see fit in the future. We're presently working with Trig on the supply of radios, transponders, GPS sources, and a bunch of other things, and PS Engineering for the audio panel. We get those questions a lot, so I'll answer that here. We're also in the process of porting the digital cockpit, which has been prototyped in a Windows environment, to the target hardware. And what you can see in that little image at the top is the development board of the target hardware that will actually run the UX on the aircraft. And we've now got that, well, we're about to install that over on the avionics test bench that I'll take you to in a second, and got all that connected with all of the peripheral systems so that we can test as we go through development. One of the areas that we're going to showcase for you shortly is the area of synthetic vision. So one of the issues that I have is a lot of synthetic vision systems are not terribly well set up for VFR helicopter environments, where we're not overly bothered by the terrain. We're much more interested in using the terrain as a 3D context for obstacles, wires, and all of those sorts of things. What we've been doing over the course of the last month is gathering a source of data for terrain and wires that has sufficient credibility to make a synthetic vision system a safety advantage, rather than running the risk of presenting potentially misleading information that people would then come to rely on. So we've been simultaneously sourcing high credibility data to use within the synthetic environment, and then exploring lots of ways that we can render and display the synthetic vision environment. These are just some crazy examples that I can can show you to make the point really that you can do anything you want. Our preference at present is the muted greys with the use of some contour colouring if you've got a terrain issue, and then use 3D visualizations of wires and buildings and obstacles to really draw that to your attention. So the things that matter to VFR helicopter pilots, and so we'll go and demonstrate that in just a second. All of this stuff is being prototyped and developed on the real hardware with the actual screens, with the DigiCockpit user interface on our avionics test bench. So let's go over and see Eric. I'll introduce what the test bench does, and he can showcase how initial trials with synthetic vision are coming together. So what you can see here is essentially avionics test bench. Now the avionics test bench is a simulated flight environment. So we have an X-plane flight simulator running on the big screen, and then we've got the digital cockpit test bench that you can see here that Eric's currently operating. And what you can see at the moment is on the big screen we've got the X-plane simulated environment, and then down on Eric's screen down here we've got one version of how we can display our synthetic vision environment. Don't pay too much attention to how it's rendered at the moment. This is really a technology demonstrator for us to get the mapping and the rendering and all of the runtime environment working in the background, and eventually ported onto the target hardware so that we can assess the level of this stuff that we can go to within the DigiCockpit environment. And then what you can see here is that Eric's got a full screen of the synthetic vision, and then we can overlay on the top of that the digital cockpit gauges. There we go. So that's live synthetic vision synced with a simulated flight environment at the moment, with the DigiCockpit operating over the top. As I say, don't pay too much attention to how it looks at the moment. This is just proving that we can stitch the elements of technology together. So that's synthetic vision, but this test rig does much more than that. What this does is it allows us to verify and test each and every element in the avionics system as we develop it. So we don't rely on, you don't assume anything is going to work, you don't rely on things working out the box. Everything has to be tested. So what we've got here is a control panel that simulates some of the flight controls that you'd have in the aircraft. So the plus and minus buttons you can see here, and the frequency flip buttons are the buttons that you would have on the cyclic. Again, these are just buttons for the test rig, they're not the ones you'll have in the aircraft. We've got some mode switches up here to control push to talk or hot mic. We've got undercarriage position switches to trigger signals in the digital cockpit environment, and then of course we can plug in the pilot and co-pilot and passenger headsets to route into the intercom and get all of that stuff working properly, working with the IPI and all of the other stuff that we've developed. And again, as I've said, the actual hardware devices that form the backbone of the DigiCockpit, approved, TSO'd, certified devices from Trig. So this is your ADS-B transponder. This is your PS Engineering intercom system. That's the secondary head unit that we're using just to verify that things are working properly with the radio, with the transponder. And then we've got a single com radio here, space for the second com radio and for the marine radio, and you can see all of the wiring looms are starting to be developed and tested, and the processes and ways that we do all of these things are being proven on test right now. And then down at the bottom we've got a fairly conventional looking circuit breaker panel. The jury's still out on how we do this, whether we use conventional circuit breakers or electronically controlled ones. The guys are looking at that at the moment. So this is the avionics test bench, and this is the DigiCockpit springing from concept into life, into real hardware, and the rate of progress here is tantalizing. It moves very, very rapidly every day, thanks to Eric, Martin, and the rest of the guys on the avionics team. So really pleased with how all of that's coming together for us. So let's move on. So one of the other things that we're going to do with the avionics test bench and that sort of simulated environment of the DigiCockpit is to integrate this with a human factors test rig. So one of the things that we've found as we've started building more and more of the aircraft is you never really know how the thing's going to work or how it's going to feel until you've built it. So building things really early in the process is very important. And what we're doing at the moment is taking that first fuselage that we're building and integrating that with the DigiCockpit. We're looking at issues such as robust ergonomic testing, making sure the biggest and the smallest of our customers can fit, are comfortable, have got the range of movement on the flight controls that they need. We're making sure they can get in and get out comfortably, making sure we've got pull handles and things in convenient locations, and all of that really basic stuff. It sounds easy, but it's actually really difficult to do it well, particularly when you've got such a complicated shape as we have. And then other things like robust comfort trials on the seating and dealing with those irritating issues of glare and reflection. The moment we've got those windows on the front of the cockpit, we can then go through and prove that the DigiCockpit doesn't inhibit your range of vision and it doesn't cause irritating reflection problems. So all of that, the orders have been placed for all of the bits and pieces that we're having mocked up to do the cockpit demonstrator, and those bits will be coming together over the course of the next month. So just to give you an update on a couple of areas that I'm not ready to report fully yet, because there's still some very sensitive things going on in these areas. There's a bunch of stuff going on with the main rotor. It's been a major focus of activity since the event, as I think I said it was going to be at the event. And we've got some really, really clever packaging solutions to get that hub packaged within our hub cowling, which is crucial to our drag and performance. That's going really well, and we'll be in a position to report some more of that fairly shortly. There's a bunch of work going on a wide range of landing systems that go onto HX50. The conventional wheeled undercarriage, the HeliMove system, the skid system, and then the floats. We've started in earnest some concept work on the floats, which is a subtle change in direction from what we'd said we were going to do originally, but I think it's going to work better and package better. So we will update you on that, but you just leave me for a little while longer to get that to where I want it to be before I report it. The fundamental undercarriage and the oleos are coming together really nicely. We're on weight target for that, so there's no skeletons hiding in the closet there. And then we've also now kicked off a major program of manufacturing system design. So taking all the parameters that we optimize and learn here on how we make stuff, and then coordinating that into a modern and efficient manufacturing system. And one of the things that we're looking at there is the extensive use of augmented reality to support the build school, teaching you guys how to do the things that you've got to do when you come and join us at the factory, and then also how we support the field for support the aircraft with technicians all over the world. So we've got some demonstration work going on Friday this week on AR, and that I think will be a very, very important theme throughout everything we do when we interact technically with our customers and with the support operatives out there in the field. So really pleased with how all of that stuff's going. So that's the end of the formal presentation. For those of you that haven't yet attended one of the sales presentation, I would strongly urge you to go and talk to Ruben and Misha and understand the full breadth of what's been done on the program to date, as well as the snapshots I'm able to give you in these sessions. To book a presentation, just go to hillhelicopters.com, and then at that point, I'm happy to take a breath and pause for some questions. Thank you very much for your attention.
Excellent. Thank you so much, Jason. What another amazing update. It's always fun to be able to see all the latest things that have been happening. And we actually broke another record today. We've got 1,400 people that have tuned in to this presentation now. So really great to see that. And we have the questions just flowing in. We've got a good time ahead of us to be able to go through all these questions. So the first one that we're going to go over, Jason, is from Elvie. And it's one that's been addressed a while in the past, but I want to see if there's maybe any updates on it or anything like that. So the question is, how are you addressing ground resonance? Is there something that can be done to either reduce or totally eliminate the possibility of ground resonance? And will the rubber tires offer any vibration dampening other than the skid?
Yeah. So ground resonance is something that has to be handled very, very carefully in anything with more than 2 rotor blades. So obviously the main course of action for managing ground resonance is through the correct design of both the lag dampers in the rotor system and also the dampers that are put on the undercarriage system. So in terms of the skids are actually pin mounted and then have dampers to allow them to breathe and damp out any rigid body motion or flexible body motion of the fuselage itself. And then we obviously damp any lag motions up at the main rotor system as well. It is definitely true to say that the tyres make a big difference. You get a huge amount of damping from conventional aircraft tyres on wheeled helicopters. So again, it's a good reason to go wheels. But yeah, that's what we're doing. There's a lot of simulation work goes into it at the design stage, but as with a lot of things with helicopters, there's also some fine-tuning when we build the prototypes.
All right. Now we have a lot of people asking actually are these questions answered? So you just have to put your question on the chat and then we take notes of those, and one by one will be Misha and I asking Jason. So he will be answering all the questions that are going to be coming in. So next question is from Daniel. Jason, he's talking about biofuels. So other fuel options, and diesel will be a very attractive diesel fuel, biofuel, be a very attractive option because it's available at off-airport locations around the world and at reasonable cost. What are the plans to consider that fuel option, bio and diesel, as fuel for the HCS50?
So biofuel is, I would say, one of the single most important technology aspects of the program. We're not ready to disclose all of the details yet, but we're working with a very, very impressive biofuel company at the moment to develop a robustly carbon neutral biofuel alternative for all of our customers, and I think that's a really important aspect of the rollout. Well, the continued use of private helicopters, but also the rollout of conventionally powered turbine helicopters commercially. So the engine will be approved for biofuel right from the get-go. Again, you can't just approve an aircraft engine for any old fuel, because you will still want me to warranty the engine. We still have to show that it's safe to use and it's not going to degrade any of the coatings or the fancy materials that are in the engine. So to qualify an engine for a new fuel, we have to do a bunch of endurance testing on the engine. So we have to limit the number of fuels that we can approve. So obviously conventional jet grades are one of them. Biofuel, working with our biofuel partners, will be another one right from the get-go, because that's really important to us. But it won't be carte blanche, although fundamentally you can run turbine engines on a very, very wide variety of fuel. For an aerospace application, we have to be able to show that it doesn't adversely affect the long-term reliability of any of the engine's components or its performance. So we still have to qualify the fuels individually. Where there's a big enough market for that, where there's a big enough demand for that, absolutely we'll do it. We're very much on our customer's side, but it will have to be rational. We can't do everything.
Okay, excellent. So this is something that has been asked in the past, but again, same thing, we'll go over it again. Are you able to be offering auto blade folding at some point in the future? And I think the more important part of the question is, will you be able to retrofit? So if you've ordered the manual blade folding kit, will you be able to retrofit it for the auto blade folding in the future?
Yes and yes. So yeah, you'll be there will be an auto blade fold. Obviously, there's a huge number of things that we've got to do. The moment we've got the basic aircraft sorted, then we've got a whole bunch of options that people want, and we've just got to work through the list. So yes, it will become available as soon as we can do it.
All right, from Dual Parks, he's asking about special tools for maintenance. Is there any special proprietary tools to provide maintenance for the HCS50 and the HC50?
For the maintenance that we expect to be done in the field, probably not. No, there isn't anything there at the moment. If it does become available, they will be inexpensive. because our whole philosophy is about making the aircraft easy to support and inexpensive to support wherever you are in the world. So there's no intention for it. But again, I've got I can hear Craig shouting at me at the moment. When we did the main rotor transmission, there was all sorts of quirky little tools and things that would make assembly and service of the transmission easier. But it's whether we do that sort of thing in the field or whether we end up just offering field replacement modules, service exchange modules for stuff like that, and do that back at the factory. So the idea is we do the easy stuff out in the field because it's logistically a lot simpler, and it gives us control over the bits that you can that need to be looked after very carefully. And in that case, I don't really expect you'll need very much at all.
Okay. Just to expand on that, just from my understanding, so are you saying then in between the 5,000 hours for that gearbox, you wouldn't really need any tooling or anything to do any maintenance or certain to that gearbox, and then at the 5,000 hours is when you would just essentially take it out and replace it with a new one?
That's right.
Yeah, okay. Excellent. Our next question is from Jocko, and he's in South Africa. So the question is specific for South Africa, but I'm going to generalize it to the rest of the world because I think it's applicable everywhere, so you can kind of make it more general. Will there be support structure in South Africa?
Yeah, there will be support everywhere for this aircraft. Now, again, we've answered this before, and my response will be consistent with what we said before. We have to be realistic. We're starting from a standing start, and we've got to roll this capability out progressively. The way the HX50s will be supported in different countries around the world to start with will be every aircraft is sold with a maintenance training course. So you can bring your favoured mechanic if you're already a partake in the helicopter fraternity. You will have somebody that already looks after your existing machine. We will train that person for you to look after your existing machine, and then your aircraft comes with a maintenance account, so those designated representatives have access to our tech support team back at the factory. So we'll make extensive use of things like AR and all modern methods of communication to be able to support and help people in the field and give you factory grade support wherever you are in the world. But this will build up progressively for the HX50s by bringing in your mechanics or bringing in designated mechanics for you, training them, and then they can come back home to you. As the business grows and we develop a distributor network and appoint maintenance partners all over the world, then it changes again, and then there'll be local boots on the ground through independently approved maintenance organizations. So it's a progressive approach as the fleet rolls out.
Excellent. So I have another question, which is more of a client interaction question, so less technical. I can answer that one easily. Is there a list of buyers, U.S. buyers by state with contact information? And Ken is asking that, can you publish that list of owners by U.S. and state? So we cannot publish any information without the consent of the client, but we do have the Hill app that we're going to be launching some new features very soon. So those features are going to be excellent to connect with other owners if they allow that, and it's going to be a local community base. We're going to be launching for the US specifically. We have a lot of orders from the US. We're getting very close to 200, so there's a lot of good critical mass in the US. That's going to be available by region. Okay, that's the answer to that question, launching very soon. Now, Misha, you can pick up the next one if you want.
Sure, absolutely. So I'm just going to go to Antonio for a moment, and his question had a couple different facets too. I think the most important one is just about performance. So he is in Peru. Obviously, there's some high terrain there, and so he's wondering, is the HX50 going to be able to fly in areas where, let's say, cities are located at around 3,500 meters?
Yes, so we can essentially hover the performance, the key performance parameter that we've guaranteed is the aircraft will hover out of ground effect at max gross weight at 10,000 feet on an ISA plus 15 day. And that is essentially a better performance than any comparable helicopter. And so yes, we've got the best performance of anybody on the market. If you bring those numbers to me offline, I'll do the performance calculations for you for that specific application. But you've got to remember that there's two things that play into this. Firstly, we've designed the GT50 to make sure that it can deliver its flat rated values all the way up to 10,000 feet on an ISA plus 15 day. So there's no degradation of performance based on the engine. So you've got all the power that you've got at sea level up at 10,000 feet. Obviously, the engine can do much more at sea level. But then on top of that, the way that the HX50 aircraft has been designed is generous. So you've got a low empty weight, and the thing is designed to carry 595 kilo people in each seat, 3 and a bit hours worth of fuel, and still be able to deliver this performance. Because you've got such a generous payload allowance, in almost every application, you're going to be well below max gross weight, and that gives you another huge margin on performance when you operate just below max gross weight. So I've got no doubt that the performance will more than satisfy you.
Okay. Very good. And then we have from LV Miller a question about the second question, exhaust question. And it is, I assume that upward pointed exhaust is the quietest design. Isn't there an issue with snow or rain going into the engine? Is it going to require an exhaust cover when parked outside in slow or raining conditions?
Yes, it will require an exhaust cover, but that's not just because of the snow and the rain. It's to stop all sorts of other things getting into the engine. The engine exhaust is equipped with a drain, as a lot of other helicopters with upward pointing exhausts are, and so you won't ever accumulate any significant snow or rain in there. So yes, it is something that we're aware of. It's one of the trade-offs for having the exhaust pointing away from the ground and the people that you can irritate with the noise.
Okay. The next question is coming from Daniel. It's a fairly long question, but I'll go ahead and read through it. So coatings and post-processing have proven to be very cost-effective options for increasing durability, reducing wear, extending low or no oil operations, reducing friction losses and heat production, and enhancing heat tolerance. Is Hill considering bringing PVD-type coatings capabilities in-house or other post-processing such as super finishings or cryo treating? With 500 horsepower input or output, it would not be unusual to see a reduction of 10 to 15 horsepower in the gearbox's losses, which would be added to the available power profile while enhancing fuel efficiency and the safety envelope from the loss of oil pressure during the flight.
Okay, so if there's two sides to this, and I think I've answered a similar question to this previously. So when you're designing a critical set of systems like a gas turbine engine, high-speed reduction gearboxes, main rotor transmission, it is all about integrity and reliability. So there are things that are modern coatings and modern processes that you can use that offer performance benefits. But we have to qualify all of those. We have to prove that they'll last the life of the gearbox. We have to prove that there are no long-term or corrosion mechanisms or any other degradation mechanisms that you might not have seen in other applications that can affect or reduce that coating. Because if you're dependent on it, it has to be there all the time. So if it degrades or deteriorates during an inspection interval and you depend on it, then you've got a problem. So we've actually taken a very conservative design approach to how we do the gearboxes, how we do the engine components, to stick very much in the comfort area of the approval authorities, of the experience base of our engineers that are developing these components, so that we have great confidence that we get what we're expecting to get. Now, some of the things that you've said that doesn't apply to. Super finishing, we're all over that. Yeah, we're really into super finishing. It has lots of amazing applications for us, and it'll be used in a bunch of places on the helicopter. And yes, that will be brought in-house. The consumables are pretty inexpensive, and the kit you need is very cheap. So things like that, definitely. Some of the more elaborate coating processes, it's very much a trade-off between whether the potential performance or efficiency benefits materially outweigh the risk of us as an organization, not having sufficient experience to know that it's going to work in practice over a 50-year life, because getting data for those kinds of extended periods is very difficult. So some of the things that you suggest we are doing, we're all over. Other things, not just yet. And the helicopter performs just great based on the design formulation that we've got now for how we do the gears and how we do the engine components. So we keep a watching brief on all of these things, but I do have to get these things past the aviation authorities, and to do that I need huge amounts of data, which is time consuming and expensive to generate. So it's not quite as simple as if it works in racing cars, it'll work in helicopters.
Yeah. All right. Antonio has a simple question, which is, if I place an order now, when is the expected delivery date, so ETA time? So since we have 540 orders for the HS50 now, we're estimating that delivery of the mid-500 is going to be end of 2025. Obviously, the sooner anybody orders, the sooner they will be in line of delivery. So that one was easy to answer. Now, Dwell Parks has another question, technical question, which is, what are the TBO of this aircraft and the cost per hour? Now, Misha, I know that you have that cost per hour right there ready, but probably Jason can comment on
the current
TBO,
number that we're using.
Because of
the current number that we're using for the operating cost is $313 US an hour. Obviously, that's fluctuating a little bit right now with the exchange rate difference and also the cost of fuels. So that's a bit of a ballpark number on that operating cost. But Jason, maybe you want to touch a little bit more on the TBOs.
Yeah, so the whole aircraft has a 5,000 hour on condition TBO. So that, for a typical private owner, that's 100 years of flying time. You know, for sporty pilots that maybe do 100 hours a year, it's 50 years. And for the real serious flyers, it's 25 years worth of flying based on how long it would take you to burn those hours off. So it's a lot of hours. But in real helicopter terms, it's not a lot of hours. The big commercial machines that I worked on originally were designed for 15, 20, even 30,000 hours in terms of the key components like the fuselages and the dynamic components. So it's not a difficult thing for us to be able to do, but given that we control the airframe and the engine, we've harmonized all of that around 5,000 hours. And it's a modern on-condition maintenance approach. So you don't have this 10, 12, 15-year calendar death date, which essentially drives the depreciation of the aircraft and drives up that real operating cost. And the other thing I would say is Misha's given you an operating cost there based on a given duty cycle, a given usage. Is that 50 hours, Misha, or 100 hours a year?
It's 100 hours. 100 hours a year.
On 100 hours. So the more you use your helicopter, the lower that operating cost becomes, and the less you use it, the more your fixed costs dominate the operating costs. So what we've done from a philosophical point of view is to fundamentally control all of the fixed costs that you're going to have to pay whether you use your helicopter or not. So the insurance will be through an organization that is through us, basically. We're forming a mutual insurance company so that we can control the insurance and keep that cost down to enable as many people to be able to afford to operate a helicopter as possible. And then similarly with the maintenance, because we're vertically integrated, because we make all of the bits, we control the part prices, so we can keep the cost of part replacement and overhaul of the mechanical components down to something sensible as well. So we're doing everything we possibly can to drive that price down to a level that's really never before been seen.
Excellent. Ruben, you want to go ahead with the next one?
Okay, Hull has... yeah, I can go with that. Can you please spell out what is the buyer's involvement? I suspect it is on the build, because with the plant. So can you actually go over some more details? What could I expect as an owner of an HS50 to go to the plant and participate in my build? What is it going to look like, Jason?
Okay, so that's what Martin is developing right now. So I don't have the finished answer because we haven't finished designing the process yet. But fundamentally, You are required to build 51% of this helicopter, and you will build 51% of this helicopter. There's no excuses, there's no workarounds, there's no way that it can be avoided. But you have to remember, this is a helicopter that's been designed to be manufactured in a factory. So the total time to produce the helicopter collapses down to a relatively small period, which is why the build school concept works. Now, if you look at the underlying FAA rules and the underlying FAA checklists that they use, things like transmissions and engines and avionics and rotor blades and rotor hubs, you're not expected to be involved in that. So it's really the components that are left, such as the fuselage. So you'll be heavily involved in laying up composite panels, infusing, working with the preparation of the fuselage, the bonding operations. But again, this is something that you'll be supported by our staff and our equipment to do this in a really enjoyable and efficient way. And then you'll also be involved in the assembly of the aircraft, in the layout of the control runs, and in pretty much everything else that is on that list. But it will be done in the context of a really, really efficient manufacturing system with the latest AR and multimedia ways of explaining to you at every step what you've got to do, and then supervising and checking that every one of those processes has been completed properly. So that's the way the hands-on aspect of the build school will work. But in addition to that, because it's such a well-organized process and we've got time to do it, you'll also go and see, and to a certain extent be involved in how we build gearboxes, in how we put the engine together, in how all of those key components that are critical to flight safety work and are assembled, so that you fully understand how your own helicopter works. So it's in part it's a process that's fully compliant with the FAA regulations on what you've got to do to qualify as owner built, and then in the other part of the process is it's a very, very rich educational experience to make you a safe, independent owner operator.
Excellent. The next question we have is coming in from Deacon. And just a note on a previous one from Daniel. It was just more of a comment about the app and the social aspect of the app, and just want to put a general comment out there that the app is something that is going to continue to increase. So, it started as a base app and it's continuing to grow now, and there's more community groups that are being added onto it and so forth. So that keep looking for updates on that, because that's going to continue to expand with lots more features and benefits on there as well. But the question that we have here, Jason, is a little bit more of a future question. So I don't know if you want to spend too much time on it, but will there be a twin Hill helicopter produced in the future?
There'll be lots of Hill helicopters produced in the future. So we're interested in two things beyond HX and HC50. A twin-engine, more capable machine is one of them, and a hybrid machine is another one of them. And we've got a bunch of technology, early-stage technology development going on at the moment that will allow us to select which route is best for us. The biofuels piece is integral in how we do that, and there's potentially a new and more efficient version or future derivative of the GT50 engine in that mix as well. So I don't want to declare too much about it, but you can expect bigger commercial helicopters from us in the future.
Mm-hmm.
All right, Gary Reed is asking about what is the final size of the cockpit screens?
The final size of the cockpit, they're 15.6 inch standard modules. So they're exactly what you saw at the event, Jerry.
Excellent.
Right.
And then is the CAA still fully supporting the project? Do they see any issues with certification? This is from Jonathan.
Yes, they're fully supportive of the project. I'm sure there'll be many issues with certification. It's a complicated process. So, at the moment we're focusing on organizational approvals and whatnot, which is the first step of that process, and then we'll roll out our formal approval and certification plans with them. The CAA have been nothing but supportive to us to date. I've got nothing but good words to say. It's a demanding period for them, upscaling to their new responsibilities, recruiting new staff and new specialists, but so far they've done a great job for us.
Great. And Martin is asking a little bit further down the line, beyond the 100 years that you mentioned, Jason. So what happens after the 5,000 hours? And is there a possibility, from what I understand his question, do you carry on and see if you can even certified hours after 5,000?
Yeah, so I mean, all of the key
5,000 is quite a
components have.
bit.
Yeah, the 5,000 hours is really set by a period after which you need to have a look at your mechanical bits. So at that point, there would be an overhaul on the major mechanical elements. The engine would need some attention, the transmissions would need some attention, flight controls would need some attention, and the airframe would need an inspection. So we'd do, at that point, you'd do a mini overhaul. We wouldn't expect that to be terribly expensive. I can't really put a meaningful price on it yet, but it won't be a lot compared to what you're used to at the moment. And then the machine's good to go again. So to put it in perspective, the airframe, the blades and things like that are designed for 20,000 hours. That's the design duty on those sorts of things. So for heavy use commercial machines, the mechanicals would just get overhauled and reused, and the airframe and dynamics would go on as long as they could before they picked up sufficient service damage to need replacing themselves.
Okay. Next question is from James, and it's a simple one. Where is the attached location for the front wheel when you're doing ground handling, so manual ground handling?
For manual ground handling, what the attachment for the dolly?
I think
it's on.
I think it would be for a tow. Yeah, for a tow machine. Yeah.
It's on the castering portion of the wheel.
Okay.
Again, that's an area that's receiving a lot of attention at the moment. As I said, the undercarriage is being detailed right now, so there'll be much more to come on that in subsequent updates.
Elvi is asking a technical question, and it's quite long, but I think it's I can go through it all. It says about the mast. Is the mast and rotor hub using any ideas from helicopters like the Estrom or the BO-105? These masts and hubs seem simple with no rotor failures to date, if I'm correct, but they might have some drawbacks too. Any combination of mast and rotor ideas from Estrom or EC120 or BO-105, or are you learning from them all and making the best hub ever designed?
Well, we're trying to. like everything else, we're doing it. Like everything else, we're doing our best not to invent anything new, because it brings with it too much technical risk and too much uncertainty. And if you look at the history of new rotor hub developments over the years, they're often followed by crashes and development mishaps and things like that, which we really don't have the time for. So our hub design, like a lot of the work on the helicopter, is really an exercise in good mechanical engineering and good industrialization. We're not inventing anything clever with the hub other than the way that we've packaged it within that cowling. That's something that lots of people have tried to do over the years, and very few people have done it well. So a lot of our attention and a lot of the decisions that we're making on the hub are very much about our specific mission, which is creating a helicopter which has benign handling qualities, is robust in turbulence, rides really sweetly, but packages so that we've got a nice high cruise speed without needing lots of power. So at the moment, I don't really want to declare exactly what we're doing with the hub, because there's some bits in there that we need to patent and we haven't yet. But I think the best way I can describe it is, when you see it, you'll think it's very clever and very sensible. It's not a super duper rigid hub. It's not a copy of anybody else's. It's our take on how best to learn from what's been done over the years and package it really nicely.
Very exciting. And a question from Carl. Any thoughts or plans on changing the type of seat impact absorber system? Still planning on doing the carbon fiber crush tubes, or is there a different idea?
Yeah, it won't be carbon fiber crush tubes. There's a different idea. But again, I've got to be sensitive in what I say because we haven't protected it yet.
Okay.
So, Carl, if you think about the ones you sent me pictures of, it's not dissimilar from those, and it packages really sweetly with the legs.
Good, excellent. He understood that one. All right, so Alan has a very, very common question, and it is a very important question. It is, when do you expect making the first flight of the HS-50? a whole helicopter? I think this was answered in the event, but you can go and answer yourself again, Jason, about the expected flight of the HX50.
Yeah, it is exactly as per the event. So by the middle of next year, we expect to have the first of the ground demonstrators together with all the systems together, and then we should be flying within next year. Well, first flight within next year.
Excellent.
So no change.
And from Charles. Yes, Charles has been with us for a long time, a 100 Club member, and he's asking about insurance. So insurance for turbine aircraft is very expensive, particularly for pilots with low turbine time. How have insurers responded to the insuring of an aircraft based around a new engine from a new manufacturer, in addition to the discussions re the subsidized replacement costs?
Yeah, so again, the insurers that we spoke to date have been very, very supportive. You know, they can't give you a firm quote until we turn up with a finished helicopter and they can see what it is they're insuring. But that's and the indicative numbers that they've given us are on a par with what you'd see for existing helicopters. But like so many things within the organisation, we're going to take control of that situation ourselves through our mutual. Obviously, it doesn't cost me the same to insure a HX50 as it would cost a third party because I control all the parts. And we're just going to use that fact to have end-to-end control over the insurance. So essentially, we will create a mutual insurance company that will then provide cost-effective access to insurance wherever you are in the world. Now, we may well split that out, so we will handle the hull insurance, and it might be that there's a local part of liability insurance that you'll need to deal with locally, or we may split the two up. It's all to be detailed, but fundamentally, with insurance coming directly from us, it'll be much more cost effectively than you used to. The other point that I would raise is that the high cost of turbine insurance traditionally was because of the high cost of turbine engines and the ease with which you can do something very expensive to them. That doesn't apply to HX50. You know, our engine is not expensive. And the FADEC control of the engine mean that it's really not possible for you to do any damage to the engine using the helicopter normally. And if something does go wrong, basically it's something that's wrong with the machine or something that's gone wrong. So I don't see the differentiation in our application that we've seen historically with turbine engines. So don't expect that to be punitive. It won't be.
Roy is asking, are we still on target with costs, both CapEx and OpEx? I think the OpEx has been already covered by Misha on the operating costs. Now CapEx is, I imagine, will be relatively linked to that in terms of what is the investment and the impact of the hours that the aircraft has available. But you want to add anything there, Jason?
Yeah, cost is an area that we're doing remarkably well on. The systems that we've produced here have come in exactly where I expected them to be. Obviously, we're experiencing some short-term hikes in material costs at the moment, but I expect that will have settled down by the time we're producing anything in volume. And there's many ways that we can improve the prices that we're paying at the moment for materials by utilizing the vast volumes that we've now got. Because all of these special materials, the gear steel, for example, the super alloys, there's not that many people buy them. So the moment you start making a significant number of aircraft, you've got a reasonable position to go negotiate. So now I'm very robust about costs across the platform and across the program. It's the least of my worries.
Excellent.
That's clear then.
The next question is from Dr. Paul Becker, and this one's a little dear to my heart because he was a student of mine many years ago. And he's asking, how do you maintain strict tolerance from prototypes to production and keeping the cost down?
Because we just buy more of those machines and do exactly the same thing. Simple as that. These processes that we're developing are not prototype processes, they're production processes. That's why you hear me laboring the point about process development, is because what I'm building here is a mini version of my 335,000 square foot production facility. So you will see exactly that machine in duplicate in the factory with exactly that work holding and tooling. And so there is no there is no difference. There's obviously some statistical behaviors, which is what I talked about with the gears and the bearings earlier in the presentation. So once you've proven that you can make one, the next thing you've got to do is prove that you can make 100 and understand how the trends in tolerances vary with different things that can vary during a production cycle, and make sure that you've robustly got control of the process. But all of that work is being done right now for each of the parts that we're developing, hence why we're spending all this time up front doing it. So just buy more toys and do more of it. That's all we've got to do.
Very good. Well, these questions are very interesting. Keep them coming. We still have want to finish in about 30 minutes max, but going to have a target of 2 hours of total session. We still have about 29 minutes now. So if you want to ask more questions, keep on writing them. The next one is very simple. Can you land on the belly of the aircraft if the wheels don't come out?
Yes. Fundamentally, you can. Structurally, you'd be better off doing it on soft ground because of the shape of the fuselage. But yes, it can be done. It's not a problem structurally.
Excellent. The next question is from Gregory. Will the U.S. customer HX50s be classified as an experimental?
Yes, that's the plan at the moment.
Okay. And will that have the need to have experimental labeled on the side of the aircraft?
Possibly, but that's subject to negotiation with the FAA, because unlike a lot of traditional home builds and experimentals, this aircraft is fully compliant with the latest certification standards, and it's built in a production-approved organization. So there may be some leeway there, but I need to go and have that conversation with the FAA, and I can only do that at the appropriate time. So we've just got to go through development, get it working, demonstrate that we are everything we say we are, and then we can go and have those conversations.
Is the safety system certification required, and what is being done to meet it? Not sure if that question makes sense to you, Jason.
It is required, and it's in hand. We're going through, we're treating it, although we may not need to give all of the certification compliance showing materials to the authorities. They will all be prepared in readiness for HC50. So all of that activity is being done, and there's a whole bunch of stuff being done at the moment for requirements tracking, compliance showing, full certification plan for aircraft, engine, avionics, everything. So it's a full strength certification process. And when I mentioned earlier about the organization needing to grow up, we're making the changes in the way that we work and the way that we operate to reflect that that's what the next chapter of the program needs to be about. So all of that stuff is ongoing at the moment.
Okay.
Very good. Next question has been answered already, but I think it's important because we have obviously new people that are joining our sessions, and it's about what is the process of certification in the European Union, certification, we go over that, and Belgium specifically. Can you go over that? What is the steps going to be taken to achieve?
Are we talking about HX or HC?
I think it's HX50. I think the certification is being meant to be permit to fly. Yeah. Mm-hmm.
Yeah. So in the European Union, EASA do not have anything to do with amateur-built helicopter and amateur-built aircraft. That's all handled by the national authorities. So the approach is a uniform approach to what we're taking all over the world. The initial basis for approval, the initial certification, is being done here in the UK, and that's essentially going to be a full strength certification exercise from our part, and then we'll provide what agreed evidence the UK Civil Aviation Authority require to get our initial permit to fly, and then the associated operating limitations and parameters. We then take that and work our way around all of the international states, whether it be US, Canada, or the European countries, to go and then get that recognized or parallel approved in each of those countries. But again, until you've got that first one done, and until you've got the paperwork, until you've got all of the documentation, there is no point in trying to go and do that 50 times in 50 different countries around the world, because they're all going to ask you the same 50 questions that you can't answer until those materials are there. So I understand it might be frustrating, or it might be looming in your mind that that's not done yet, it is normal. It's normal for where we are in the process, and we've got to do this systematically and diligently, and we have to drive that process. So it'll all be at our expense. There'll be no costs beyond your normal registration fees and things for you to bear. All of the approvals process for first of type in a country will be done by us.
Excellent. Next question is from Glenn. As a self-built helicopter, what are the limitations of flying this in an urban area? And then also just a reminder again of when the commercial version, the HC50, is going to be expected to be available for delivery.
Yeah, okay. So in terms of operating limits, again, the basis for the operational limitations are they're drawn from the basis for approval. So if you're a Part 27 helicopter and you're fully compliant, that's what you make your case for your operating limitations on. So for us, day and night VFR in accordance for whatever your local regulations are for Part 27 helicopters. That's what we will be pushing forward with all the authorities in all the territories. Obviously, it varies by country, so there isn't a one size fits all.
Good. Misha, can you pick up the next one? I was just
yeah, sounds good. So Charles is asking. Yeah, Charles is asking about an update on the autopilot. Has there been any updates going on that?
No, that area hasn't moved a lot recently because it kind of hangs off what we're doing with the DigiCockpit and what we're doing with the gearbox and the servos. So we have design concepts for the electromechanical servos that drive deliver the autopilot functions, but the core software will follow from what we're doing on the DigiCockpit. So we have a plan for that, but we've not done much more with it as yet. It's a little lower down the list. What I need to do at the moment is focus on the things I need to get onto long-term test. So a lot of the focus is on the big structures, the big mechanical bits, and the big spinny round things.
Okay. Can you elaborate more on the type of torsional and lead lag damping technology?
Elastomeric. That's about as far as I'm prepared to go.
Okay.
It's sensitive because of what we're doing at the moment. So yes, it's elastomeric. It's maintenance free. So.
Excellent.
Okay.
And from Giuliano.
Sorry.
So yeah, fully electronic instrument panel, not having any steam gauges in case of a complete electrical failure in, let's say, a night flight. What is being thought as a solution? I understand the concept of just look outside, but sometimes it is just not enough, for example, in night VFR flight.
What do you mean by a complete electrical failure? Because the architecture has two independent screens with independent backup batteries. You've got a generator, which is essentially two generators with independent wiring and coils on them. And then you've got a backup battery as well. So it is extremely improbable that you would lose all electrical power to everything and have no capability. You've then also, I mean, these machines will always be flown with an iPad or whatever follows on from iPads in future years. So you've got an independent source of navigation and situational awareness there. But fundamentally, it's a VFR helicopter. You should be able to fly it by looking out the window. If you're not able to fly it by looking out the window, you're not in VFR conditions, are you?
That is correct. Yeah,
Stay home.
Even at night. And just to reiterate on that, is it still the plan that you would have the ability to get your flight instrumentation, your basic flight instrumentation on the Hill app on the iPad?
I don't understand that question. Say that again. So the app.
You're talking about basic navigational and situational awareness with the iPad. So, but would the iPad actually be able to display the main primary flight instrumentation as well as a backup? Do you understand the question? So
yes, I do understand the question. My comment was really about treating that as using the functionality that's already within the electronic flight book apps, whether it's ForeFlight or SkyDemon, OzRunways, whichever one you choose to use. There's a two-way Wi-Fi link between the iPad and our system, so it's quite possible to push that stuff through. We haven't done anything about that yet, and that's one of the things that will come out of the work that Martin's doing at the moment on the safety assessment and how we manage the system, the failure modes, and the training, and bring all that together into a consistent safety argument.
All right, Charles from Australia is asking any update on the FADEC development. What challenges are there to both qualify and certify the FADEC? If my memory doesn't fail, there are 2 redundant FADECs, right?
Yep, there are two redundant FADECs. We did a bunch of work a little while ago on hardware selection, and we're currently about to kick off another phase of control law development. There's a natural tendency of engineers to overcomplicate these things and to put all the sensors you can possibly imagine into the thing and have all sorts of whizzy functionality that makes it very difficult to certify and quite unreliable in service. So I've been pushing back quite hard on that. And we're essentially developing a FADEC that is little more than an electronic implementation of a hydromechanical speed governor with a start and stop function. So we're trying to keep it very, very simple so that we can run it on very simple hardware with the minimum burden for software and hardware certification. So that's a hot topic within the organization at the moment.
Okay. And Alex is asking an interesting one, probably not very probable, but have you thought about integrating SpaceX Starlink internet into the helicopter?
I have thought about it. Because that opens up all sorts of opportunities for us, which would be very useful. But I haven't done anything about it, and those dishes are quite big and heavy.
Yeah, probably not very probable on this case.
Oriented all the time. I'm not sure about that. I think they have to update their systems first, right? I have one,
yes.
And I can tell you that that antenna is always moving. So it's not that easy to have in flight and moving antennas.
No. But the idea of a space-based broadband system is very appealing to us. We've just got to wait for it to mature.
Yeah.
Mm-hmm. Jason is asking, upon delivery, will there be a specialized team who will fly out to assist with assembly in Australia? Probably can go over that engineering that goes first to the UK or to do that, but that's the question.
Yeah, exactly. So as part of your build school program and synchronized however you want it, we will have trained your local mechanic or a local mechanic in your area so that you've got support back on the ground when you get there. We won't send our own employees out to Australia to do that. There's lots of reasons why we can't do that.
Excellent. Okay, and Sean is asking the question, please clarify if the digital cockpit screens are touchscreen units. Also, will they be capable or capacitive or resistive touch?
They are capacitive and they are touchscreens.
Okay. Easy to answer. Now, Oscar is asking, I'm really worried about the subject of the engine. Turbine engine manufacturers take years to design, prototype, build, certify an engine. Will this be happening with your engine on the required time frame?
Okay. Which turbine engine manufacturer are they referring to? Because the C250 was done in 57. And the other engines were done more recently, but a long time ago. So I don't think there's any real recent comparable engine development been done on an engine that is this simple. The only other organisation I can think of that are doing it is another startup organisation that are producing small recuperated engines, and they've done it on a very sporty timescale as well because they are a small agile organisation. So the other thing that you mustn't get confused about is that there is a massive difference between developing the technology to make small gas turbine engines for the very first time and just pulling together a bunch of very well understood technologies and processes 70 years later. And we're doing the latter. So we're taking known machining technologies. You've seen we can make compressors already. Shortly, you'll see our cast blisks coming together. Shortly, you'll see our fabricated structures coming together on the equipment that we've built and developed. We have a pool of people that come with a wide range of experience of design and manufacturing gas turbine engines for aircraft and industrial applications for decades. And so we're not actually learning any of this stuff, we're just applying what's already known. So yes, developing an engine is a complicated thing to do. Yes, it will go wrong on the test bench and we'll have to sort a bunch of stuff out while we're doing it. That's just the nature of what we're doing. But what this process will result in is the very first cost-effective gas turbine that allows us to create a helicopter and a bunch of other aircraft afterwards that will completely reinvigorate general aviation. So the juice will be worth the squeeze, I assure you. I can't say for 1 minute that it will be a trouble-free development. That would be pretty naive. But we're robust, we're confident, and we've got all the skills, knowledge, and finance we need to be able to do it. So just leave it with us and watch as we progress.
Excellent. Sean's asking a question, might have a couple technical corrections to be made on it, but I'll read it anyway. So on engine failure, one must get the collective down ASAP. There's a huge collective down time response between the Cabri G2 and the R22, as the Cabri G2 spins the rotor much faster than needed for auto rotation. Will this be the same for the HX50, so we won't need to apply the R22 death grip on the collective? Maybe just a quick discussion on inertia there.
Yeah, so HX50 has essentially a high inertia main rotor system. So you've got it'll feel more like a Cabri than a 22. The 22, as everybody understands, for lots of reasons, has a light rotor system, and that's not the case in the HX50. The other thing I would say is with the type of rotor hub that we're designing and the blade manufacturing techniques that we're using, we're able to put a greater proportion of the mass of the rotor blade further out, so we really get a significant increase in inertia over what you can do with mechanical bearings, putting a lot of weight at the root of a rotor blade, as is the case on some older helicopters. So no, you can expect it to be much more benign. You've still got to pay attention. It's a single engine helicopter, but it'll be much more benign than some of the things you've flown in the past.
Okay. Now, are there any restrictions of flying within a controlled airspace, the HX50? That's from Pedrek, and he has a PS, reading Misha's and Ruben's book, The Epic Dream, sitting by the pool with a cool beer. Well, enjoy the book. Thank you for taking and reading our book. But then Pedrek is asking this question about controlled airspace with the HX50.
So as I said earlier, the operating limitations should be in line with any other Part 27 helicopter. They will vary around the world as the local rules of the air change, but I don't expect it to be any more punitive than what you'd get in a conventional Part 27 helicopter.
Okay. Peter's asking a good question, actually. Would you need to send in the oil every 50 or 100 hours for analysis? That's sending it in to Hill helicopters.
We may well do that, yes.
Okay.
It'll be again that will be subject to what goes on in the transmission testing and the engine testing, but we may well do that.
And that wouldn't be for 50s; it would only be for 100s, because for turbines you don't do any oil changes on 50s, correct?
Yeah.
Yeah, exactly. Okay.
Darren is asking, is there a safety certification, and where are you currently in the safety certification process?
We're at the early stages of that, so we're putting all of our all of our approval processes. Let's not call it certification at the moment. Mm-hmm. We're putting all of our approval processes together as we speak. That's what our current activity is all about.
Yeah, excellent. And we still have quite a few questions to get through here. We've got about 8 minutes till we'd like to start closing down the session. So we'll see how we do in the last little bit here. Frank's asking the question, are there any plans to use a non-wetting surface treatment on the leading edge of the main rotor blades?
A non-what surface treatment?
A non-wetting.
Non-wetting.
I'm not familiar with this.
It's probably
No,
non-wetting. I assume that it doesn't, the liquids will not stick to the surface.
yeah, okay.
Yeah, I don't know if
Can we
this is
treat
like
it
a
for that?
de-icing or an
Again,
anti-icing application.
yeah.
Type of,
So
Mhm.
again, at present, our strategy is to keep as many of these sorts of things in critical areas of the aircraft as conventional as possible, because we have a mountain of approvals to climb. If I start throwing in random bits of new and novel technology everywhere, it's just going to make the approvals process really difficult and time consuming. So you can expect a thick metallic erosion shield on the leading edges, which is as per every other composite bladed helicopter you've ever seen in recent history. So don't expect anything unusual. Remember, we are industrializing the helicopter, making a beautiful, high-performing helicopter at a cost-effective price. I can't also go and invent a bunch of new technologies at the same time. We'd never get the job finished.
Mhm. Now, regarding, we know that the front side has a lot of glass, Jason.
Yeah.
So what windshields, wipers, defogger systems, what is the plan there for
Yeah, so there's
those?
obviously, as part of the climate control system, there's a robust defogging system. We're not doing windshield wipers because they generally don't work very well on helicopters because of the shape of the noses, and they scratch the perspex. But with it being such an aerodynamic shape, the moment you get the thing moving, it'll soon clear the rain off the bubble for you. And again, it's a VFR helicopter, so if it's raining so heavily you can't see, you can't fly.
Okay.
And then in terms of other questions, we often get asked about the glazing. The human factors demonstrator that we're about to put together will start working through some of the coatings that we're using to keep the IR, the UV, the heat, and the visible light out of the cockpit, and then manage glare reflection. So we'll have some practical demonstrations of where you can expect to be on that fairly shortly.
Okay. And Shane's asking an interesting question. Since we're buying experimental helicopters, can we customize to our desires at the factory? For example, can we swap out cameras for thermal imaging?
So legally speaking, you could probably do that, but just remember that what we're doing is approving this helicopter essentially to the full certified standards, and we're going to great time, effort and expense to put a compliance showing pack together for all of the authorities around the world, on the basis of which you'll get very flexible operating privileges. If you mess around with it too much, you will invalidate a lot of that. And so it might not have it might not be as attractive as you think it is. We'll provide absolutely everything that there is a rational business case for in terms of options. I want people to love their helicopters, so customizations on the interior, customizations on the exterior, any roll equipment that people want in any kind of volume, we will do as soon as we possibly can. But I will actively encourage people not to mess with the helicopters after they leave the factory or a maintenance facility, because this isn't a crude helicopter that we've knocked together in your backyard. This is a sophisticated aircraft, and so it needs to be treated as such.
Mm-hmm.
Charles is asking, what is the minimum pilot weight? Any further progress on the trim tank?
Yes, there's lots of progress on the trim tank. We're doing that right now. The minimum pilot weight is currently 70 kilos. We will explore whether we can do anything else with that, but it's unlikely. So I think 70 kilos is likely to be the practical limit for that. The trim tank is one of the most contentious parts of the aircraft that we've got here at the moment, because it's an incredibly difficult area of the aircraft to package. You've got large keep out zones for the flight controls. You've got complex areas in the structure. We've got a nose wheel to package with all of its actuation. We've got to manage all the crash cases, and we've got to get a crash proof fuel cell of a large enough volume and a useful shape in there. So we've been running around the Maypole for quite a while on that, trying to find something that keeps all the disciplines happy. So I think that will be bottomed out in the next 6 to 8 weeks, once and for all.
Okay. And Steve's asking, are you looking to manufacture in the UK?
Yes, absolutely, and we always will.
Very short and concise.
Joe, any updates on the struts?
Which ones?
Not sure.
Not sure.
So undercarriage struts, Oleos, yes, they're steaming along. They're in a great place. Very simple, very elegant. We've got a very nice way of locking the undercarriage down, which is very compact and mechanically robust, simple and inexpensive to manufacture. Gaz is doing a great job on that. So pleased with where they are. They hit the weight target, which is nice. So all good there. In terms of the struts that support the main rotor gearbox, they're very conventional at the moment, and they're staying conventional for this version of HX50. As I said in the event, and I've said previously, we will revisit that as part of a broader ride refinement package and look at some active vibration control, but that's not something that we can do now. That will be part of a future suite of technologies that get rolled out across the platform.
Excellent. And BH is asking about long-range fuel tank options. Will there be a long-range fuel tank beyond the conventional 5-hour, 175-gallon tank that's installed in this helicopter?
Well, you say 5 hours, but that's 5 hours at max continuous fuel, max continuous power. If you fly at best range, it's longer than 5 hours, So yes. I don't know how far he wants to fly. I don't know how good his bladder is. But yeah, it's possible. It's possible. We don't have a plan for that at the moment because we think the fuel tank's big enough. But if there's a real need for it, then yes, we're open to it. There's room in the baggage bay for lots more fuel if you really wanted it, subject to being within CG. It'll be challenging for CG in there.
Mm-hmm.
Excellent.
I think Ruben and I have proven that a 5-hour fuel tank at a normal cruise of 140 knots will be sufficient to get you pretty much anywhere in the world. So
yeah,
yes. And that's
if anybody's got a real application for that, do let me know, because we're always interested in corner points for the operating envelope. So if there are some applications that we haven't thought about, it's always good to know at this stage while we can still do something about it.
Yeah. Misha and I will always say that beyond 5 hours, you will need a different type of tank that is empty, something else. So be practical on that one.
Yeah.
All right, we have time for the last question. We're reaching right now the time to close it. So I'm just going to ask one last question, then we can close it. Jason, we've been here 2 hours. Amazing, great questions from everybody. We reached a great number of connections. I don't have the last number, Misha. I think
2,000.
It's close to 2,000.
We just crossed 2,000
right?
People that have been watching
2,000.
today.
Amazing. Yeah. So great record here. And the last question is, Jason, gear warning system, emergency gear drop system. And that is from Freddie. He's saying, thank you very much for the progress. And actually he has a previous question I'm going to answer right away, which is from, hey, any orders from Fort Worth? And that is in Texas. I checked, and there is 17 from Texas and 1 from Fort Worth. Okay, so we have that information right there. But Jason? Yes. Last question. Go ahead.
So, in terms of emergency gear deployment, we've got a manual system that unlocks the uplock. A very conventional uplock systems in wheeled helicopters tend to be a simple catch that's right on the verge of opening all the time. So a simple mechanical lever or cable will allow it to unlock and start to deploy. And then at the moment, the system that's scoped into the undercarriage is a pneumatic blowdown. So it just evacuates the hydraulics and blows the gear down. There are a bunch of other ways we can do it. That's the favored approach for now. We'll see how it does when we test it.
Yeah, wonderful.
Very good. Well, we reached the end. It was phenomenal, this session. It was a while, just after our second global meetup event that we had beginning of August. Thank you very much, all of you, for attending from all over the world. Again, we surpassed 2,000 connections. Have a great day, afternoon, evening, wherever you are. And great to see you, and hope to see you again on the next one, next update.